Hello everybody and welcome to another Cinder video. This is installment 2 of the Simple Intuitive Solution series. The first one was a parallel, this one is a simple search. I think that search is incredibly important and it's a very complex thing to solve, right? Searching, when you start including fuzzy searching and things like people misspelling things and what's expected, that can be very complex. But my hope is that this will be your introduction into searching and how can you build out a simple and intuitive search that you then, as a developer, can iterate on. So it can be sometimes scary when you go in and you search something like how to make a search, in JS, and you get some maybe crazy things that pop up, and these might be great solutions, but they might be solutions that might be over engineering the solution that you need now. The solution that I'm going to show you now I use on real life websites for clients, and I go through it here. It might only cover 40 cards, but I don't need to query 100,000 rows. I don't need fuzzy searching, and if that's what you need, you can definitely iterate on this. So as every tutorial starts, I will go to the boilerplate, but let me show you what this will look like. So imagine you have 4 cards, and I come into here and I say, okay, I want customer 2. It'll come up with customer 2. Maybe I type in John or JA or just J. There's only 2 J customers in here, and only these will come up. Same thing for the table. If I type in chair, the chair row comes up. And notice that it's not office chair that comes up, it's the entire row. And that'll give you an expected response that I want the whole card to come up. I want the whole row to come up, and we'll come back to this as we're building this out. So let's start with some boilerplate, and we'll go to just a basic HTML file, and we'll open a live server to show what's going on. So, 2 search fields for 2 sets of cards. The reason why I have 2 is I just wanted to show you that maybe you have a table application, maybe you have a card application, and show you the context for both of these. Now, I have a search input field where I'll be searching the cards, and I have a table search input field where I'll be searching through the table. You could have these as the same thing, but in the case of this, I'm imagining it. This is one application and this is another application. So let's get started, and we're going to start with just the cards for now. Now, let me kind of take you here. This is searching is the idea of a needle and a haystack, right? So you have a needle, you have a haystack. Your needle is the search field, the haystack is what you're searching against. But it's important to know that when you have a positive match, for example, maybe I have John Smith in here and I want to return this. You need to decide what is the smallest unit that you will return back to the user. If I have a John Smith, will I return back the paragraph that I found? Or will I return back the whole card of the paragraph that I found? And in most use cases, I think you would return the whole card or the whole row, but maybe you don't care for the whole row. Maybe there's a lot of extra information. Maybe you don't want to show the person the email. You just want to find the paragraph that they were looking for. And so as we work through this, let's come down here and start binding what we actually need. So I'll open up a script tag, and my search input is pretty self-explanatory. That's the search field that's up here that's going to correspond to where I'm putting in the actual text that I'm searching against. My cards is who I'm searching against, but also it's the smallest unit that I'll return back to the user. If I wanted paragraphs or emails, then I would only be searching this email, this email, this email, and I'd put an emails class on this. Instead, I'm putting a cards class, a card class on every card. So this is both what I'm searching for, but it's also the smallest unit of division that I'm searching against. So when I'm hiding and showing things and I only want to show you the 3 cards, I'll do that instead of maybe, only showing names like that. Okay? So from here, I'm now going to bind a function to my search input. So instead of coming in here and adding a button and doing an on click, and so now the user has to click the button or press the enter sign, how about every time the user presses a button or keys up, that we will run our search function. And so this will work for small data sets, maybe not massive ones where you have hundreds and thousands of rows. You don't want to query everything at once, but this will work great for a small data set, maybe like 40 table, 100. I mean, I've done this with a pretty bad, modern browsers can handle it pretty well. And so we bound a event. We said, take our search input and bind this event to it. We're going to add a listener that every time we press key up on it, we're going to get the text that was written. So then We'll take that text and we will visit every single one of our cards. I'm going to visit this card, I'm going to visit this card, and every one of those cards I'm going to say, hey, does this text exist in here? And if not, I'm going to delete it. If the text exists in here, I'm going to say, yeah, good. If this text does not exist in here, I'm going to hide it again, okay? And so to do that, we're going to take all the cards, we're going to for loop through all the cards, we're going to visit each card using that for loop, and then at each card level, we're going to ask, hey, does this code exist, or does this kind of search code exist there? So let's look at it here. We took a for each loop. It said cards for each, and we got the element. So it'd be the same thing as if you're for looping through it, but this is for each code. And I'm going to say, okay, get the card text. Now, why am I doing two lowercase? Well, that's because maybe you typed in, you forgot to capitalize John, but John is capitalized in your card. You'd want to say those are equivalents. Now, if you were really strict, you'd get rid of this. And if you're a little loose, maybe you would also trim white space. Maybe I want J space O to return JO as well. So this is where you would adjust that. And then you'd go card text.include search text. This is what's actually asking, does that card text, the card that we're visiting, include our search text? And if the answer is yes, show that. And if the answer is no, let's hide it. And so for every iteration, we're going to come through and systematically hide, show, hide based off a positive or negative result. Who are we hiding or showing? We're showing the actual card, and that's what we specified up here. And that's it. We're done. So if I came in here and I said Jane, it's going to hide Jane. If I type in J, and if I type in J-O, it's going to go John Smith. And like we said earlier, J space O is not going to return anything because there is no J space O. Now, if you wanted J space O to return John Smith, you would then trim the white space off of it. Okay, let's do the same thing for the table. And basically the tutorial's done. You can click off now and start coding away and apply this to your solution. But I'm going to abstract this solution, okay? I'm going to abstract the solution so that we can more easily implement this on, let's just say we have a pretty big website and I wanted to implement it here, there, and everywhere, okay? What I would do is I would make one function, okay? I'd make one function called bind search. And so what this does is the same way we had a search input, well, I'm going to have to write this code all over again for my table search. And I'm going to have to do table cards. Let's just take in an input ID, and let's take in a parent ID. Wait a minute, parent ID? I thought we were searching through basically each individual child. But if you notice this, card, they're all just children of card container. So how about we get all the children from card container, and that's the same thing as we had cards up here. Now, before you kind of get confused and say, what is array from? Apparently .children doesn't return an array the same way .querySelector all does here. It turns a live HTML connection, and so we convert it to an array by going array.from. Super weird. That's JavaScript. You run into these, you search it up, Stack Overflow tells you what's going on. And then we have this show style. Show styles depend on an is table. So if table, we're going to use show style table row, show style block. What is that? Well, where we were showing with block and hiding with none, that's not going to work for a table. If I add block to this table row, it's going to collapse the column for some reason. It's going to look super weird, and I can show that in a second. But essentially, now we're done. We took everything, we just replaced search items and search items. That was the same, right? Search input to cards and search items, right? And then everything else is the same except for show style, and then we're just taking in these values. So when I'm ready to bind something, I'm going to bind search. I'm going to bind search to card search input, and that's my card container, card search input, card container. Again, searching those children, and those children now become the smallest unit. And if you need to be more granular, you can just adjust that code, but that's code that will work for me. And then I have a table search, and I'm going to say, yeah, this is actually a table. So let's see, did that work? Chair works, and does customer work? I just realized that this is the other one, but it's the same code. In the end, it's the same code. I just wanted to show you what would happen if we were using display block here, as we were earlier. If we did display block for the table, oh man, my keyboard just had a day. See how when I do wireless headphones and I do display block, it doesn't like it, okay? It collapses those columns. So that's the tutorial. Thank you for watching. Again, the code is on cinder.org. The link will be in the description, and hopefully you understand now how a simple search could work. And notice that it's still kind of intuitive. You're still it's still super responsive. You're getting your search result really quickly. But again, if you might need something a little bit more complex, you could adjust each individual steps of this. Maybe you need to search in 2 sets of data, and you would probably have 2 of these search items here. If you had a table and maybe a grid, you might have to have an extra Boolean here. If you had too big of a data set, maybe you'd have to make this not key up, and maybe you have to do this when you had a, sorry, my rice cooker just went off. That's the Zojirushi, and I'm not sponsored, unfortunately. Maybe you'd make this an on-click function, and then maybe you want to make this search text comparison more fuzzy. That's what fuzzy search is. If I make this, kind of like, hey, what if I get like a 30% match, and it gets really complicated from there, but you now know this is the level that I would do it at. All right. Thank you so much for watching.